So this is Math 1103, session 9.3, saving money. Um, so for this one, it's pretty much the same thing as before, where you're looking for the right formulas and then use it onto the right problem. That's it. Now, for this first problem here, use the formula for present value. So you need to look for the present value formula. Now, what is present value? We talked about future value in the last unit. Future value is what is when you have an investment, right? Future value is what you would have in the future at the end of this investment. It could be 10 years, 20 years, 401k. Present value is what you put in right now. So you're like, well, why do I need a formula for that? Well, let's just say you want to retire with $1,000,000, right? The question is, let's say you know the interest. You know how many years you're going to put it away for. You know how much deposit you're going to be putting in. Now let's calculate how much money you have to start out. That's the present value. So the question is, how much money do you need in the beginning to result in a specific amount in the future? That's basically it. So now the first question says, use the formula for present value to calculate what you need to invest right now in a lump sum. So lump sum means you're not going to get any deposit. You're not going to, so it's not like your retirement, your 401k, where you put money in every month. This is a lump sum. You put it away and forget about it. So let's see, some formula. Now let's look at this. You want to have, so let's see, you want to have $25,000. 10 years later, with an APR of 12% compound monthly. All you gotta do is go to the formula. Right here. You see this formula, right? Present value formula. So basically, in this case, your A, which is the accumulated amount, that's the future value. You want $25,000. T equals 10 years. APR, that's the rate. That's 12%. That's 0.12, right? And what is the compound monthly thing, right? That's n, which is the interval, equals 12. And all you gotta do is put this guy, these four numbers, into this formula right here. So that will be, again, it's a lot easier if you type it in yourself. So if you just write it down on a piece of paper. But let me try this. So 25,000. This divided by, oh, actually, I can do better with this. Should I draw like a line right? There you go. Like this. 25,000 divided by, the bottom should be 1 plus range is 0.12 divided by 12, right? And then it's raised to the power of 10 times, let's do 12 times 10. Now, when you get problems like this, my advice is to kind of solve this one at a time, one step at a time. Now, some of you guys who are good at the calculator, just put everything in there, that's cool. But for me, I just go ahead and do like this. This is equal to, so the bottom right here, right? So that's 25,000. I'm just gonna get a freshen thing going. The bottom is gonna be parenthesis 1 plus 0.12 over 12. You can always put in a calculator if you want to. 0.12 divided by 12 is 0.01. So 0.01, which is 1.01, right? Let me just go ahead and do that. 1.01. Raise it to the power of 120. 12 times 10. And just put this whole thing in the calculator. Now, when you put in the calculator, you have to be very careful. Here's my rule. I put parentheses over everybody in the numerator, then parentheses for everything in the denominator. So it'll be parenthesis, 25,000, close parenthesis, divide, that means fraction, parenthesis, right? 1.01, raise it to the power, this button right here, 120. Now, some of you guys who don't have like a graphing calculator, you just have to do one step at a time. Enter. And you will get 7574.87. Done. Pretty easy if you know how to put a calculator. There's no actual algebra or anything involved. So this guy has 18 years. It will take $250,000 to obtain the contract for 4 years. So this guy is trying to put money. This guy's trying to put money into an account to save up for $250,000. So let's see. You should have, in this case, for this problem, you should look at U1 A equals $250,000. All right. The time is gonna be 18 years, and the interest rate is gonna be 0.12, and you are doing it compound monthly, so n equals 12, and all you gotta do is put this whole thing back in the formula. So for me, I just go ahead and do it right now. Oh, that's 250,000. So like this, 250,000, right? Like this. Let me see. Like that. Put the wrong button. Divided by parenthesis. I'm gonna try to put everything together in one shot just to see what will happen. And you know, you can practice to see if you can get it done. If not, just do step by step. So that's 0.12 divided by 12, and then close parenthesis. Right, that's right. Raise it to the power of 12 times 10, or 12 times 18. Make sure you have another round of parentheses like this. And I got 29,142. Let's try that. 29,142.26. So again, it's kind of messed up. You know, it's easy if you have a graphing calculator like this one. So, like I said, if you need this one, then just let me know. I'll try to get you one of these copies. All right. So now, if you go to the next problem, this one's a little bit different. This one is the IRA. IRA account, basically, you can think about this as 401k account. All right. So you are trying to save some money by making a deposit each month. So that's very different than what we got before. Before, you put a lump sum. Right now, you got a deposit. That means every month you put the money in for the next, well, however many years, right? You have to use a different formula. So go to the PowerPoint. That is called an annuity, where you are either putting money in gradually, like constantly, every so often, or you're taking money out every so often. So in this formula, FV, of course, is the future value. It's how much you want in the end. What's PMT? PMT is the payment per interval. So what interval we're talking about? It depends. So in our case, it's monthly. So it's payment per month. And of course, the hours is the interest rates, right? And it's the interval of payment. In this case, is how often you pay a single payment. This time, in this case, it's monthly payments, so N would be 12. And T is the time. Again, it's in years. So let's see about this guy. So what this say is, we know that the payment is going to be $400, and we know the interest rate is 0.06. That's how much you gain the interest for this particular IRA. 6% is actually pretty fair. Usually it's 4%, sometimes 9%. Right, currently if you buy, I say 9%, 12%, because yeah, you gotta, market's taking a step down. Like you bought like last month, then maybe 2%. But anyway, let's look at the years. Or and it's 12 because you're making monthly payment, so you're making 12 payments per year. And let's see the time. T equals 2L. He started out at 30 years old, so 65 is when she gonna retire. 65 minus 30 is 35. So there you go. So take those numbers and again plug into this guy. Now this one's a little bit tricky, so I'm gonna try that. So there will be 400 times. And I'm gonna draw like a fraction here. Let's see. No, this one's gonna be rough. It's gonna be 1 plus 0.06 over 12 raised to the power of 12 times 35, right? NT, right? Then minus 1. Right? I'm gonna make a bit bigger. So that's the numerator. The denominator is going to be a lot easier. It's going to be R over N, which is 0.06 divided by 12, just like that. And I'm not going to try to put all this in the calculator in one shot. What I would do is this. I'll figure out what is this guy on the top first. So I will have 1 plus, actually improve parameters. 1 plus 0.06 divided by 12, right? And then raise it to the power of 12 times 35, right? Just to see what that equals to, and then minus 1. So I know the top is this guy, so that will be, so let me do this again, 400 times, at the top will be 7.1236. I just rounded to 4 decimal places. You probably don't need that many, but that's just easier for me. And let's look at the bottom. Let's go with 0.06 divided by 12. 0.05. So 0.005. And all you gotta do is put all this in the calculator and clear this. So that'll be 400 times 7.1236 divided by 0.005. Enter. And I got this. So this is how much. Let me say, how much money you will have in 35 years. Provided the interest rate is correct. Let me see. 6%, 35. Just to be safe, what I would do is I'll look at the answer just to check. Sometimes you see how this is so close to the other. The reason why they say this is wrong is because I didn't run it to like a lower number. So I guess just to be safe, right? What I would do is in the future, like the number on the top, right, the numerator, I'll just do like this. 1. So 1 plus 0.06 divided by 12, right? Raise it to the power of 12 times 35, right? And then minus 1, right? So that was the number on the top. So I'm going to use this number. Now you could just copy all the numbers down, it will work. So maybe let's just do that. So you could do 400 times this rate. And I just want to let you guys know you could do this 400 times second this ANS. Basically, that is the answer from before, which is this number, and then you can just divide by 0.005. But not everybody uses calculators like this. I'm just gonna just type in the whole number: 7.123551494, then divided by 0.005, and let's see, yeah, it works. So you see the numbers. So yeah, so that lesson is just put in every number. Don't run it to 4 decimal places. I know it is a little bit stupid. On the test, if you get it wrong because of that, it was so close, I just give you full credit. Now, let's look at the other problem. So Kelvin deposit this much money every quarter. So let me go ahead and type this in. So this time the payment is 1220.33, and the interval n equals to 4 because he's doing it quarterly, every 3 months, right? Quarterly means 4 times a year. Into this account for the college fund. Now he wants the future value to be 95,000. So he wants the future value to be 95,000, and the time frame is 15 years. Interest rate is 0.034, right? 3.4%. So the question is this: how much interest will he earn? Now, this is a tricky problem because before you start using the formula going crazy, notice that they already gave you the answer in a way. The future value is $95,000. That's how much he will have 15 years later. You just have to find out how much he will put in all this time. Now, obviously, he didn't just put in 1220. He put that in every quarter. So let's see. Let's calculate. How much did he invest over the 15 years? Well, let's see. He is making 1220 payments. So the payment times n, right? Time, because he's making quarterly payment, times the time, which is 1220.33 times 4 times, right? He making quarterly payment, and he making those payment for 15 years. So let's put this in the calculator. 1220 times 0.33 times 44 or 4 times 15, and I have 73219. That means this is how much money he paid into this program all his life, over his lifetime. Well, then that's the case, right? Remember I said that the future value, or the accumulated amount, the A, right, minus the present value, that's the interest. How much you have in the future minus how much you pay into the principal, right? Or you can just say this: the overall amount you get minus the amount you pay equals to the interest that you earn. So all you gotta do is do $95,000. That's how much that you have in the end of this investment, minus 73219.8. That's it. Let's see what that equals to. So let's see, 95000 minus 93219.8. I got 21780.20 cents. So let's put that in the put this guy in here. So Kelvin, he would deposit. How much did he deposit? 73219.8. That's how much he put in all his, throughout his life. Interest earned is 221,780.20. There you go. It's a tricky problem. Not a lot of math, just multiplications and subtraction. You just gotta understand the problem. So now for this next guy, suppose that you save enough money to pay cash for your next car. The goal is to save an extra 24,000 over the next 5 years. So already you can tell that he is looking for a future value of $24,000. That's what he wants. Okay, and that's for a time period of 5 years. And he knows the interest rate would be 0.045. That's 4.5%. And he's gonna invest. He's gonna deposit that his payment quarterly. Well, what is missing? The question is, how much do you have to deposit? How much do you have to pay into this particular investment to get to 24,000? So it's the payment. That's what we're looking for. Well, in this formula on the left lower corner, it's looking for the future value. That's not what we want. We want to know the payment, so it's the same thing, right? Type it in, 24,000, right? That's the future value, times. Now let's see. Let's draw a line right here. Right, the top is gonna be, and I know it's a pain. It's gonna be R over N, which is 0.045 divided by 4, right? And the bottom is gonna be 1 plus 0.045 over 4, and raise it to the power. What's NT? 4 times 5, and then minus 1. It's very similar to the last problem. It's almost like the opposite, right? Because you're looking for the payment this time. So let me be real safe. So I'll put it at the bottom first. The bottom, if I put in the calculator, is 1 plus 0.045 divided by 4, right? Let me go ahead and do the parameters as well. And then raise it to the power. 4 times 5 is 20, right? So I'm just going to do 20. And then minus 1. So that is the denominator. So let me see. I just realized I forgot about the parameters. So this guy would be 24,000 times. And let me go ahead and put this in the calculator as well. 0.045 divided by 4. So that will be 0.01125. The bottom is going to be 0.250750528, and that is a fraction. Go ahead and put a line between, just like that. So now let's put this in the calculator. So that will be 24,000 times 0.01125 divided by 0.25 075 05208, and I have roughly 1,076.78. Oh, 0.77, my bad. That's basically how much money he got deposited per quarter to get to $24,000. So again, using the formula, that's all. It's better if you write it down on paper than to type it up like this, because that's not gonna happen. This is very hard to understand, but unfortunately, I do not know how to write on this computer here, because I don't have one of those fancy tabbing. There's a laptop that, that don't have the the writing capability. The money went into the graphic card, so I can play FIFA on. But now, let's look at this here. They wish to save money for 10 years, so how much do they need to deposit? So this is the same type of problem. Basically, all you need to do is look at, we have a future value. You want 200,000, and you get 10 years to do this. The interest rate is 0.06, and let me see, you are looking at a monthly payment, deposit per month, and equals 12. Then the question is, what's the PMT? Use the same formula, you will get the answer. So try this out and see. So let me just get to the next problem. Let me see. Suppose you wish to retire at the age of 65 with $80,000 in savings. Determine your monthly payment if your APR is this, and you begin making payment at 20 years old. It's the same thing. So let me just kind of help you out right here. So again, this time you know your future value. You're looking for the monthly payment. So that's why we're sticking with the same formula. All I gotta do is think about it. Okay. The future value is $80,000. That's how much you want. You want monthly payment for, let me say you start out at 20 years old. You retire at 65. That's 45 years. So T equals 45. Then the interest rate is 0.075. And monthly payment means 12 months, right? So 12 payments, right? So you're looking for PMT. So again, it's the same thing. Put into the calculator and figure it out. So skip that. She was to retire with 1,400,000. When she turns 22, she began making deposit money into the account with the interest rate of 7%, and that's a monthly payment. But what monthly payment does she need? That's the same problem. So try that out with the same method, and you should get it. So Chase does an IRA. He deposits $400 per month, and when he retires at 65, his future value, right, is 558,000 something. Determine how much money he deposits over the length of the investment. Now, don't go too crazy with this one. Just think about the question. The question is, how much money did he deposit over the entire life of this investment? Well, just think about this, right? This is very similar to the earlier problem we had. That's tricky, but it's not very difficult. All you gotta think about is this. He made $400 per month. He deposited $400 per month. You multiply that by 12. That's how much he put into the account per year. And he did that from 30 years old to 65. That's 35 years. That's it. Just multiply. So let me use the calculator. 400 times 12 times 35. And I have a good $168,000. That's how much he paid into. So now, here's the deal. He got this much. So the total deposit is $168,000. How much interest did he get? Subtract from this number. So there will be 558,638.87. Subtract 168,000, and you get, this is how much interest he generated. That's very good interest actually, but that's the key about 401k. You do it over a long time period, don't mess with it, and you're gonna be winning at the end. So that's that. So this guy deposited those money, future 565,000. How much of the wild will be deposited? So this is the same thing almost. So you just gotta think about this, right? The first thing you should do is think about the question. They are asking you how much will he deposit into this account throughout his life. for the 15 years. The problem is they didn't tell you how much that he deposited. You got to find that out first. So, but we did that earlier, right? From we're using this formula, right? So the future value is 85,000. The T is 15 years, and the interest rate is 0.036, and he's gonna be making a fixed monthly payment, so n equals 12. Right? So we gotta find the payment first. Right, let me do this one here because this one's a little bit tricky. So put into this formula, we have 85,000 times. So once again, it's going to be a fraction. It's going to be parenthesis 0.036 divided by 12, and the bottom is going to be, let's see, 1 plus 0.036 divided by 12 raised to the power of 15 times 12 times 15, and then minus 1, just like that. So once again, I'll put the bottom piece in the calculator, make it a little bit easier. So it doesn't matter, which way you do it. You can put the top in first, because we're gonna do it separately anyway. So like that. Make up the fraction first, like this. So let me put this in here. You know what? I'm gonna put the top in first. Does it go in order? So that's 0.03, 0.003, 0.003, like this. 0.003. Now what about the bottom? Let's try. Parenthesis 1 plus. I know 0.03 because I've already put in the calculator a second ago. So close parenthesis, right? Raise it to the power of 12 times 15, which is 180, and then minus 1. So that should give you 0.71462022309. So again, use that information to put in the calculator. So that would be 85,000 times 0.03 divided by 0.71462022309. Check. And I got. So here's the deal. The payment. Remember, this is the payment, right? The payment equals 3568.32. 33, my bad. So that's the deposit that he has to make per month for 15 years. So the total deposit would be 3568.33 times 12 months. He's doing monthly payment, right? And then times how many years? 15 years. So let's multiply that and see how much will he pay into this investment. So he would pay in 642,299.4. That's how much money he would put into this account throughout the life of the loan or the investment. Now let's look at this. Future value is 85,000. So he will get. Well, one second. I'm afraid I made a mistake somewhere. That's too much money, right? There's no way I can put that much money. I only got $85,000. Let me see. Which part did I mess it up? Let me try this again. I'm gonna put this in the calculator here. 85,000 times 0.003 divided by 0.71462020309. Oh, I missed come on, too many zeros. My bad. So let me erase that. But this one. So the payment turned out to be 356.83. There you go. So let's try this instead. So 356.83 times, let's say we paying 12 payments per year, monthly payment for 15 years. So let's see what that equals to. I have 64,229.4. That's more like it. So let's try that. 64,229.40 cents. How much interest did we earn? Well, that's not too bad because look at this, right? You can look at the future falls 85,000. So let's just do 85,000 minus this guy, 64,229.4. And that interest that he generates is 20,770.6. There you go. It's a lot of, it's hard work. It's a lot of crap you gotta put in there, but you know, that's cool. That's good enough. It says I'm not ready to certify, but you know how it is. All of this is because I skip a bunch of problems. So basically, try that. And I know if you don't have a good calculator, it's gonna suck. I absolutely understand that. That's why you can always try some of those web calculator. Like if you can go to I always go to Wolfram Alpha. This guy. You can type in those math problems. Like you can type in 1 plus or minus plus 0.03 divided by 12, and then raise it to the power of 12, something like that. So they give you the formula like this, right? So this will help, but I get it. It's not easy, right? If you're new to how to type math into operation into the keyboard, into the computer. So another way to do is MathWay. MathWay is a little bit better in terms of, like you can go to algebra right here, and you see how they have the fractions and stuff like this. So that's a little bit easier, just a little bit. But so you can do like that, and then you can type in 1, I don't know, 12. You can do another fraction in there, like 12 over 0.03, and then you can put another one here, 0.05, and all. You fatty already. So they actually give you the answer here. So that's 8,000 for this one. So, I mean, there's no perfect one, but I know this, whatever stuff I'm giving you right now is way better than your cell phone if that's what you're using. So, but anyway, just let me know if you have any problem, and that's the end of the session.